fascinating tour of the shop floor at the Cummins Darlington engine factory. We're now going to have a look at its pilot centre. Pretty much, I mean, this, you could say, this is your skunk works, isn't it? This is where it all happens, all your R&D and your testing. So to talk us through it, we're going to kick off with Alex Ross. So, I mean, Alex, we are in what you guys call the pilot centre.
Yep.
What do you do here, in a nutshell?
So, pilot centre, so a pilot installation centre. So we do all the mule testing, mule vehicles, all the brand new regulations and engines that come through with that, and put them into vehicles, things like that, different types, trucks, buses, tractors, combines, diggers, excavators.
So you'll literally see it all at display, anything and everything.
So we will see it from start to finish, so we'll do the development work and then we'll go through the current product. So engines that are being manufactured in the plant as of today, we'll often look after those. Any issues that come through, we'll do troubleshooting work, we'll do testing work, validation, and pieces like that.
Well, that's it, because like last time I was here, which was a few years ago, I had a quick look around this area in the pilot centre, and I didn't realise that you guys actually, you'll build full prototypes for your customers, you know. It's not just, here's an engine, crack on sunshine and try and make something of that. You'll actually get their machine here and build them a full prototype, go right through it.
We will depend on what we're doing, so sometimes we don't just delve into the world of diesel, we go into electric and pieces like that, new power that it's called. So especially with those ones, it's no longer a diesel powertrain. We'll take a diesel vehicle and we'll put a full electric powertrain in. So that's something where we're doing the full system. We get a rolling chassis and that's it. We've got to do everything ourselves and electrify it, or similarly with the diesel, we'll put the engine in, new cooling pack, new gearbox, a lot. And make it integrate it and make it work.
I'm going to say, because it's all going to talk to each other, aren't it?
So that's the biggest challenge we face nowadays. Is, I suppose, 10-15 years ago when I first started, it was very much, it was just sit an engine in, swap it out, and it's a few
mechanical injection, mechanical gearbox, levers.
It's all good to go. Whereas now we're moving into the realm of the engine is just another building block in the full vehicle, and again, it's got the electronic modules on there. It has to talk to the brakes, it has to talk to the adaptive cruise, it has to talk to the transmission. There's lots of different modules in there that sit within the vehicle that we've got to try and integrate. And often we will work with new OEMs, and sometimes they'll challenge us and they won't give us all the information. So we've got to work it out. We do a lot of benchmarking, a lot of backtracking to make sure that when we put ours in, it'll integrate and it'll work as best as possible.
And is that relationship that you have with these OEMs, is it quite a flexible one? Because, you know, like you say, sometimes you'll do a big prototype job here, but other times, will you go to their site and their facilities and do everything there?
So with the Treon, with the combine job.
Oh, the Class Treon,
So obviously spent a lot of time over in Harswinkle, working with the class team, working with their engineers, helping installation with the first 1 or 2 engines. And then also from my side, we did a lot of the testing and the tuning and the development with the transmission folks, with the class folks, to get it how they wanted it. And we're still to this day going through the field trial and bits and pieces and working through any issues or any development work that needs to be done as we work through the process.
That's it, because a project like that won't stop when the combine's gone to launch and it's out there. It doesn't stop there, does it? Because you're going to continually get data back and refine things. And
so as part of this area as well, we do what's known as field trial. So we support field trial, where that is where we'll often do it here, especially with the trucks, where we'll repower a customer vehicle from a customer of ours from the on-highway world, put a test engine in, it goes off and does its daily jobs. And from that we get invaluable data back to see what...
Well, it's real world, isn't it?
Real world. So again, we do that with a lot of them, and we'll support that. We might have launched the engine, but we might support that for 1 or 2 years after, sort of infant care, we call it. Where it carries on into the real world.
And is that the same in the ag world as well, you know? It's constant feedback all the time.
So there's a few of us here from that sort of world, and it's good to give the feedback into it. But ultimately, you need to be sat in the seat for 18 hours and ploughing and getting it wrong, and seeing that the power's not there, or this fault comes up, or whatever. So I suppose we take it from the test cells, put it in a truck, test it in the real world, and give it its full potential.
That's the only way to do it.
It is the only way to do it.
So, like a project such as the Treon Combine, how long would you be working on, or when did it even start that?
So I was involved with that from a electronics point of view and sort of real world testing point of view. It will be 2017 when we first started, but I would imagine the discussions had gone on many years prior to that. So we did one full engine development for them, the L9 for the biggest top range topper. So we developed it here in the cells and went over there. So it's been going on 5 years now. So it's released, but we're still in discussions. Although we're kind of finished with it, like you say, we're still supporting it through field trial.
Yeah.
There were some pre-series machines come out, and I think this season's the first one where there's going to be a good amount of them out there and running in the field. So.
Yeah. And like for that class Trion, it uses the L9 engine, the 9 litre, 6-cylinder Cummins engine in there. So how much adaptation or what new developments did you have to do for class?
So yeah, so with the especially with the L9, it was it was specifically made for them. So it was a standard stage 5 L9, and then it was specifically adapted to meet their needs of their operation type of running at a very single speed almost when the threshing and the combine's working. So turbochargers, fuel systems were all picked accordingly to make that work. But yes, again with the on-highway stuff with the trucks, we work very closely with Leyland Trucks down in Preston. They're kind of, again, similarly to class, a development partner, and we do a lot of testing with them and a lot of validation and a lot of work. And having that good relationship with the OEM, it means we can do what we need to do, but we can tailor it as well.
Yeah, that's it.
Accordingly for them. Like I say, with a tree on it, a full engine, a brand new engine. Yeah. Although it was the L9, tweaks were made to make it as fuel efficient as possible and as performance intense as possible as well for the customer's needs.
That's it. Well, that's it with the combine, because it's 100% all the time, isn't it?
Flat out all day long.
It's not like a tractor, it's like 50% engine load on average, isn't it?
No, so especially with it being relatively a single sort of operating speed as well. Yeah. The engines still need to meet all of the emission strategies and everything else and still pass all the legislation, but there can be some optimisation done for a specific customer, specific operation point to make it as good as possible.
And what sort of engineering challenges were involved with that L9 fitting into a Trion? Because I mean, combine being a combine, like I say, it runs flat out, it gets hot.
Heat is the biggest one. Heat is the biggest one. So, and especially with it running flat out all the time, with it running up on the torque curve all day long, for all you get hot gases when it's running really, really hot all the time. Obviously, the intake manifold, the turbo, it gets red hot. Yeah. That in a combine, chaff, straw kicking around, plenty of dust.
It's not a great combination.
It's a recipe for disaster, really. So there was work done to insulate all the hot side as best as possible. That in turn then keeps the heat in. Yeah. So for turbo longevity, we can only have limits on turbo temperatures. So we've got to kind of throttle back a little bit on what we possibly could give so that we could still make it safe for the customer. I suppose moving away from the Trion side onto the truck side, similarly with that we do sort of hot and cold testing as well, so testing for extremes of environment. Right. So we go down to Spain, Granada in Spain. Oh, terrible,
isn't it?
It's shocking.
Someone has to do it.
Somebody's got to do it.
Do you have to personally oversee that?
Yes, it's a terrible job. Yeah. Right. It's horrible. I don't like that one.
No.
We also go up to Kiruna in Sweden, so up above the Arctic Circle. So I suppose we need to ensure that regardless where we sell it, so for most trucks are probably at sea level running around Europe or the UK. Some might get sold into northern Sweden where it's minus 40, or into Spain where we go there for the altitude as well, because that obviously plays havoc with the lack of air and the lack of oxygen.
Turbo working working hard.
Overspeed and over temperature and sometimes spitting itself out the side.
But again, it's that real world testing where you just can't do that in.
No, you can do as much in a test cell or in a chamber, but ultimately you need wheels on the road or wheels in the field to make it work and tune it correctly. So.
And then, just going back to ag, obviously you've dealt with a lot of OEMs and ag manufacturers over the years. I mean, a big famous one being Case back in the day, through the 90s.
Nice Maxim.
That's it, Ed Maxim with 5.9. Got to get that one in there.
You can't beat it.
With CDC in it. But yeah, I mean, your customers today, I mean, just give us a few examples of that, because you got your Agri-Fac and Class and...
Yeah, And some of them we get in here, so McConnell with the agri buggy.
All right, yeah.
So we've had that in here a time or two for some bits of testing.
Yeah.
And then class, and then obviously the sort of pushing the ag world as well to get back in there, because Cummins was once a biggish name.
Well, that's it, but you can see you're coming back slowly. It's like you've got multiple partnerships with multiple manufacturers as well. I mean, including, you know, world famous JCB as well in there with
still
all
getting the best loading shovel in the world.
That's it. King of the clamp, isn't it?
That's
like
it,
that.
indeed.
Yeah. So, right, we can't be in a place like this and not talk about future powertrain technologies, whatever you want to call it. We can't even call them engines anymore. It's power units and things like that.
No.
What have you got going on? Where is it heading? So,
many different options, many different avenues.
Yeah.
We're currently gearing up for Euro 7. So that's the on-highway regulations. I very much suspect there will be a off-highway industrial set coming shortly.
Yeah, so there'll be like a stage 6 coming at some point.
Being muted and will probably be coming. I think we're probably one of the very few manufacturers in Europe that is doing diesel. So especially in the on-highway market, a lot are moving to the new and the future technologies. We are still sticking with diesel. It's currently sort of primary path. And we've picked quite a bit of work up through that. So we've got a few different OEMs that we haven't typically worked with that ultimately, if you're in a city centre, you're probably going to be electric.
Yeah.
But if you're running across Germany and you've got big mileage to do, or, you know, through Europe, diesel at the minute, the infrastructure isn't there for anything else. You still need to kind of do that. So diesel is our primary route. But yes, there are other technologies coming through. So there is hydrogen fuel cells.
Yeah.
So they're a primarily electric drivetrain. So motor, sometimes a gearbox, sometimes not, direct to the output. And the fuel cell is there to generate electricity from hydrogen.
Yeah.
And then the other one, we already sort of dabble in the natural gas engine market, but they're going for a fuel agnostic approach, I think it's called.
All right, yeah.
It's basically the same bottom end, and then the head is changed accordingly for the different type of fuel. So if you had a truck, for example, you could put a diesel in, and within the same space claim you could have a natural gas or a hydrogen internal combustion engine as well. So that's the other one as well, is hydrogen internal combustion. There is some development into that, and the new facility over the road, so that's the new powertrain facility.
Right.
So that's going to be capable for every fuel type that's coming through, whether it be standard normal electric, batteries, hydrogen fuel cell or hydrogen combustion engine, so it's, or diesel. So
you're really covering your basis.
Yeah.
Well, that's it. It's like, you know, winding clock back. You know, Betamax versus VHS. You don't know, or DVD versus.
You don't know where to go, and you've got to kind of cover everything as much.
And then once one starts to grow, it's kind of go with that, or a couple. Because that's the other issue, isn't it? You know, you're servicing lots of different industries.
Yep.
And within each industry, there's lots of different types of machines.
Yep.
So at some point, some may favour just battery power, some may favour hydrogen, and some may still have to be diesel all the way because of the duty cycle. So
yeah, with not being like an OEM independent engine manufacturer, there's that many different customer types or different application types, especially with the diesel stuff. Yeah, it's probably going to get phased out at some point, but another 20, 25 years, it's still got legs, and a lot of on-highway OEMs have kind of moved away from it and put their money.
It's good for you though, isn't it?
Great for us. They've put their money into other technologies, but it's left quite a big open market that there still needs to be a diesel engine there, because 20, 25, 26, when the regs come out, we aren't going to have electric vehicles everywhere or hydrogen refueling stations everywhere. So, and especially not in the ag world where you're in the middle of nowhere.
Well, that's it. It's what do you do?
Yeah,
unless you start creating your own hydrogen, which is another option, isn't
or
it?
methane.
Yeah, or methane, yeah.
So
or even this on-demand hydrogen as well, where you actually fill your tractor up with water and it makes it
does it itself. Who knows?
This is it, who knows? So it's
exciting time.
It is, like the next 5 years for you guys.
Yeah.
This site's going to look different again.
So a lot of development, a lot of money going into it to ensure that we're ready to expand and develop through the next 10, 15 years.
Yeah.
To keep up with the demand and the changing world.
It must be good for you though, as a powertrain specialist. You've got everyone coming to you. It's like, quick, give us a solution. We've run out of options.
It's time for getting some exciting and some new opportunities coming through. And makes you head scratching times now and again, but yeah, it's good.
Right, Alex, we could literally stand here and chat all day, I think,
Probably
about what
could,
you
yeah.
guys are up to. I think next time we come here, you're going to have to take us out, something,
Yeah,
you know,
show you some-
field test, things like that,
yeah.
road test, whatever. We'll do something.
Yep.
So, but for now, that's been absolutely spot on. Thank you very much for your time.
Thank you very
and we'll,
much.
yeah, we'll catch you again next time.
Marvellous.
Right, ladies and gents, we're now in the test cell area here at Cummins in Darlington, and I'm with Ryan Wainwright Fisher, who's going to talk us through. Basically, Ryan, talk us through what you do here, because it's so far from what we're seeing, it's vast, it's array, you do all sorts, anything and everything. Is that the same for you guys here in the testing area?
Yeah, so we test the engines. So what you may have seen before is the engines in the vehicles and everything else like that. What we do here is we take just the engine, put it onto a dyno, and we can run it through any sort of testing. We do a range of compliance testing. We measure a lot of emissions equipment. We measure the gas coming out of the engine to make sure we're compliant. Develop a lot through that as well. And we do mechanical development here as well in some of the test cells. So we run through, we've got set tests that Cummins have developed over the years, which we run our engines through, and they've got to pass those tests before we can go into production with them.
Right. So what, in terms of the testing, what's the difference between the testing that I've already seen on the production line,
Yep.
which is a 6-minute test and they run it flat out? Is that test purely just to make sure everything works, there's no leaks, anything like that, compared to yours is more on the development side? Is that sort of how it
Yeah,
works?
that's correct. So the testing in the factory is just a production engine. It's making sure it's run up, make sure it meets its power required within the tolerance. And as you say, no leaks, no fundamental issues, and nothing goes wrong with the engine from when it's been built. What we do here is much more development. So we'll take the engines before they reach the production line, and we'll do the development work on them. That can either be the mechanical development, so with a new engine platform, that would be making sure that all the measurements and everything else have worked out all right, it's going to last, the durability is good on it, right through to the development of the after treatment and making sure that the gas we put out from the engine meets the latest regulations.
Right.
So for off-highway, at the moment, that's stage 5, and on-highway is obviously Euro 6.
So, I mean, just talk us through the facility, because it's quite a vast facility. You've got a lot of test bays going on, prep areas, all kinds of things.
So we've got the rigging area, which is where we build up the engines. They get put onto the test pallets, which go into the engine test cell. They get aligned in there. We've got laser alignment to make sure they're in line with the dyno. We've got test measurements to make sure they're set at the right distance. So for the connection shafts, we've got all of that correct. And they get all the instrumentation we need put onto the engine at that point, so that we minimise the cell downtime, so that when the engine needs to come out the cell, take one engine out, put the other one straight in, connect it up, and everything should be good to go.
Right.
That's in an ideal world.
That's the theory.
Yeah. So we'll fit thermocouples, pressure points. We measure, depending on the testing we're doing, we can measure a lot of the around the exhaust gases inside the exhaust manifold itself. We can measure the surface temperatures.
Yeah.
We can measure the surface temperatures on that. We can measure surface temperatures all over the engine. And we can also get development turbochargers from CTT over in Huddersfield, and they want us to run them on engines and do a lot of that. So the best way to describe that by somebody I've heard is they got a turbocharger and they said it looked like a hedgehog, just with masses of thermocouples sticking out from it all over the place. And that's just measuring all the different points around the turbocharger and making sure that as we run it through various tests, we don't breach any calculated limits to make sure the durability of the product's going to be there. They can also measure things in cylinder pressures as well. So we measure the pressure reached inside the cylinder to make sure we're not going to melt any injector tips or anything like that. We don't breach the limits designed to make sure again that the engine's going to survive its life. So the power we're delivering in the engine, it can sustain delivering that power throughout the engine lifetime. And we're not breaching those limits. We can go up to crazy power, but the engine's not going to last very long.
But it's fun.
Yeah.
Fun while it lasted. So how many, on average then, how many points of data will you get out of a test? Or what can it be up to?
It can be thousands.
Thousands?
Yeah, up to thousands, because we put a number of different points onto the engine, and we'll measure those. But there's also everything the engine's measuring normally, and we'll pick up all of that as well. And we've got all the points that are on the cooling cart, which is what you see here. And then there's a number of other points within the test cell.
Yeah.
And then there's all the gas analytics as well. So there's up above us is where the exhaust gas goes, and it goes through what we call the emissions carts, and they measure a lot of things in the exhaust gas. So we can measure particulate number, particulate mass, CO2, NOx, and all of those sort of things to make sure that we can see what the engine's doing, and how the after treatment's controlling it, if that's what we're measuring on that point as well.
Right. And when you test an engine in one of these test cells, is it one test does all, or are you, more often than not, do you look for specific things? It's like, right, let's simulate a hot climate or something like that, or how's it work?
Yeah, so we do. There's a number of different tests. I don't even know them all, but we've got some which are required for compliance. So to pass an engine, to make sure that we can say that is a Euro 6 compliant engine, there's a number of set tests we have to pass. So we'll put the engine through that. And throughout development, we'll use those tests as well, because they're our sort of benchmarking points, so that when we get signed off by the VCA to sort of say, yep, that engine's good to go, we know that, okay, we've been testing it through that for the last 3 years. So by the time we phone them up to say, can you come and witness this test, we're confident that it's going to pass. So we're not wasting our time, we're not wasting their time or anything like that. We've also got the mechanical development cycles, where we can stress an engine in various ways. So we can put an accelerated life stress through an engine to make sure that the hot and cold soak cycles and things, we can accelerate those to make sure that an engine warming up, cooling down, and everything else isn't going to cause any failures such as a warped manifold or something like that.
That's it. And can you, I mean, like you say, can you actually simulate the full life cycle of an engine in a test?
To a certain extent, yes, because you can never predict exactly what somebody's going to do to an engine. You can simulate it in a controlled environment. We do have spray rigs where we'll do saltwater tests on an engine as well. So we do have certain environmental factors we can include. We can warm the test cells up. We can also cool them down. They aren't cold cells, so we can't sort of run an engine at certain temperatures and things, but we can cool the cell down.
They're not cold for long anyway.
Well, no. But we can cool them down to a certain point, but it is not what you'd call a cold cell. They're not refrigerated. But we do have blast chillers where we can put very cold coolant back into the engine, so we can switch between hot coolant and cold coolant to simulate the warm up and cool down cycles of the engine as well.
And then, because a lot of the time you'll be seeing the same engine family over and over again, but it'll be for different customers with different needs. So that variety must be huge. Yeah,
it's like you say, it's the same basic engine families, so the 4-cylinder families and the 6-cylinder families. And we tend, most commonly in Darlington, we test up to the 9 litres, but we have got a 12 litre going into test cell soon, and we have had a 15 litre in one of these test cells before.
Right.
That started to push the limits on what we could keep cool and everything. But yeah, normally we're running the 3.8, the 4.5, the 6.7 and the 8.9. But like you say, there's a number of different configurations of the engine, different turbochargers, different exhaust manifolds, different inlet setups, different torque curves on them, and we've got to test all of that. And depending on what we're testing for, what the development is, and that kind of thing will depend on what we're looking at. So one example is for the Trion combine. So we tweaked that 9 litre slightly to meet the customer's needs there. And we've got that in test cell, and we've put that through a number of tests to make sure the tweaks we'd made to the base engine, we're confident in the base engine, but to make sure we could sign it off to say, yes, we're 100% confident with that engine in that machine. The changes we made, we had to put through the tests again and just make sure that we were happy with what that changes were.
And at this point as well, do you test for or include, you know, such as the software? Because this engine's going to have to talk to, in the Trion's case, it's going to have to talk to the transmission and everything else. And
so we don't test so much of that, we're testing the engine capability. What we can do on some of these dynos, we've got different programs we can run which come into the tests you mentioned earlier, and the dyno will run in a certain way, so that can change between loading up at different set points of RPM, or through a motoring cycle as well, so we can motor the engine with the dynos we've got in the test cells as well.
Right. And obviously you're going to produce a lot of power in this place.
Yep.
Can you do anything with that power?
So the test cells are linked into the grid. So the power we're generating by running the engines is powering the test cells you see here, and we're feeding that back into the grid. We have occasionally reached that limit where we've got to the point where the grid can't take any more power off us. So we are now.
Cummins, isn't it? It produces too much power. That's what it is.
Too much power density, yeah. It's not something you say often.
No.
But yeah, so what we're doing at the moment is linking it into the factory, because the factory test cells have got the same, so they're power generating cells to try and power the factory, but because they use so much more power than we do, and they've got a larger capacity to pass back into the grid, we're linking the two facilities together so that we'll power each other.
Right.
And then we'd need to be running quite a lot of powerful engines to start reaching those limits.
Yeah.
So hopefully we've future-proofed it for quite a bit of time.
That's it. And obviously, as Cummins, you have a big family of engines. You know, you got first of all, you got a family of engines at Darlington, then you've got Daventry and wherever else, and around the world. So this test facility, you're not just doing the stuff that's coming out of Darlington. Do you do other stuff as well? And
yes, so different test facilities. We've got different tech centres around the world. One in China, India, the US, Brazil, the one in Darlington here as well. And each one's got different capabilities, different skill sets, different experience. So they use that to send different projects around the world. So there may be a project that's being run in the US, and they'll select Darlington to say, we want to run that engine there.
yeah.
And we'll look at the test cell availability globally as well. So rather than outsourcing to another test house, we'll look internally to say, okay, they've got 3 empty cells for the next 3 months.
Yeah.
We'll send the engine there and run it through that way rather than paying somebody else to do it.
Right. So when you're developing your own engine, such as, you know, like a brand new prototype engine, would that actually be built here, or where would that actually get built?
It varies. So early on in a program, all the parts would be, all the non-production parts would be sort of custom made for us as prototype parts. And then depending on where we've got resource and who's running the program, depends on where they'll be built.
Yeah.
So we've got new engine programs in the future where they're being developed in Darlington, and we've got a new introduction team which will build the engines up in Darlington as well, and then they come down here and get put into the test cells here. So,
final question then. Do you get to blow them up?
We don't on purpose. They cost a lot of money, so we try and avoid it. But inevitably, some of the testing, we do find the failures, and we have seen some impressive failures over the years. Conrods coming through the blocks and that kind of thing. Part of the development program. It's
better finding it here.
Exactly.
Yeah.
We want to find them now. I'd say it happens very infrequently now, because the sort of computer-aided design and calculation side of it has got so much better. We sort of get all of that out the way through theoretical analysis rather than putting it in a test cell and seeing if it goes bang. But you can only do so much with that, and then occasionally there can be also manufacturing defects and things which can cause that. But not very often. I think the last one was a good few years
that's
ago.
it in terms of, you know, such a design development of, you know, the engine block itself. It must be radically different compared to what it was 50, 60, 70 years ago, because they would have been over-engineering really to make sure it lasted, where you guys now can pretty much trim it down to the minimal weight that you actually need out the engine,
so
or the minimal strength.
Optimized,
That's it, optimised. We'll go with that one.
But it's also, as we've improved the power density, so if you'd taken a 7-litre engine 30 years ago, the power coming out of it then compared to now is much, much more impressive. So it's obviously pushing the limits, pushing the stress on everything a lot more. That's
well, that's it. It's like that 6.7 litre. It's, you know, it's 300 plus, 320 plus horsepower out of it comfortably.
Yeah.
That's without even stressing it, because like you say, you could probably get 1,000 horse out of it if you wanted, but it ain't gonna last.
Yeah, exactly. It'll soon fail.
Spot on. Well, Ryan, thank you very much for that. That has been perfect. Love that.
No problem.
So again, it's one of those. We could just stay here for hours and talk about what you get up to here, but Hopefully. Well, it's an excuse to come back anyway.
Yeah,
So there you go.
exactly.
Perfect. Ryan,
Excellent.
once again, thank you for your time.
Thanks very much.
Right, ladies and gents, we're now outside the Pilot Centre here at Cummins Darlington, and I'm now joined by Logan Locke, who is going to talk us through, well, your world of emissions, all things emissions.
Right.
And so, I mean, just sort of explain a little bit kind of what you guys do in terms of emissions control and developments and things like that.
Okay, so I'm Logan. I am the emissions compliance leader for Darlington, and my role is to manage all of the emissions compliance testing that we do here on site, as well as a bit of off-site work. And so there's different types of emissions testing that we do, both in the cells as well as in use, like behind us. So we'll bring vehicles on site, we'll load them with emissions equipment, and we'll test them here on site. As well as testing Euro 6, we're also testing stage 5. That's both in cells and in use.
Okay, so you mentioned there you test things in cells and you actually test them in use. What sort of things are involved in, in both parts of that?
So it's basically different stages of the product's life. So the in-cell portion, the most important piece is called COP, so conformity of production. And what that means is the engines that are produced in the plant are rolling off the line, and we basically take a quality sample of them, bring them to the test cells, make sure they're meeting emissions before we then sell them to customers.
Right, so making sure they're doing what they are doing.
Exactly.
Right.
Making sure that everything that we're saying that we're meeting is actually met.
Right.
So it's a quality check.
Got you. And then just to explain this PEM, is it PEMS test?
PEMS, yes.
Yeah. So this PEMS test, what's all that about?
So a PEMS test stands for Portable Emissions Measurement System, and that is literally the kit that's behind us right now. And so what it involves is taking a vehicle that's been out on the road, that's ran miles, that's accumulated miles, that's maybe within its useful life. We'll bring it here, we'll put the equipment on, and we'll actually run it basically around town and measure the emissions that are coming out of the tailpipe.
Right.
So it's a bit more in-depth than cell testing. You really get to see how the engine's performing out on the road in an engine that's not brand new. So it tells you a lot.
Right, so it's a bit more of a real-world test and more of a validation test to make sure it's still doing what it's doing.
Exactly, yeah, and it's a legal requirement, so it's a legislative test that we have to complete. But we basically sample all of our products, and we'll bring in, you see a lot of trucks here, but we do buses as well, and we're testing anything from a 2.8 up to an X15.
All right.
Yeah.
Right, so pretty much a big range.
Yeah, a very big range.
Got you. So, I mean, it must be quite an advantage for you guys as, an engine manufacturer that works across multiple industries and do you get to share knowledge across all those industries when it comes to emissions control and things like that? For example, can you learn a lot from the on-highways and transfer some of that to off-highways?
Yes, absolutely. So the PEMS testing specifically is much newer for the stage 5. But we've been doing the Euro 6 testing for a lot longer. So we've been building that knowledge base, for 10 plus years and using it across all platforms.
Right.
So even if it's a Euro 6, you can still use that knowledge for the stage 5.
Right, and when did PEMS testing come in to
So
force?
it's been within the last 10 or so years. So it's fairly new, actually. And for example, the stage 5 testing in-service monitoring has only been required for 2 or 3 years now. So it's very new, and with stage 6 in a few years, it'll get kind of more advanced. So all of the testing is kind of continually changing, getting more strict. We're having to do more PEMS testing, and it's kind of changing in that way.
That's it. Well, the thing is with the world of emissions, especially in the agricultural world, it was quite a fast ramp up going from stage 1, 2, 3, 4, 5, and where we're at now. It was literally like that in terms of the clean-up process of the emissions. So what's going to happen sort of between going from stage 5 to stage 6? Do we have any idea of that or timelines or anything like that?
It's a bit too far out, but we're looking at 2030 time frame.
Right, so it's a big gap going from 5 to 6.
It is a pretty big gap, and right now with the stage 5, it's more of a monitoring. So where we have limits for on-road, for off-road, it's more we're gathering data, we're measuring. Obviously, we're looking at any high measurements, so any high NOx or anything like that. But for the most part, we're just monitoring from a legal side.
So up until this point, where we're at now with stage 5, it was all about cleaning up. Well, it was particulates for a start, I think, and then it was NOx has had a big, you've reduced that one right down. What's it going to be for stage 6? Have any idea what's going to have to be reduced?
So that's a bit further along that we're not quite sure. But for Euro 7, we have a better idea. So we're going to start measuring NH3, CH4 probably. So it's going to kind of expand. And then with that, the PN, so the particular numbers that you're measuring have to be smaller.
Right.
So
can they be any smaller than they are?
yeah. So everything's getting stricter. Which is good. It's good. It's better for the environment, obviously, and it keeps us competitive because all of the OEMs are trying to compete to get our emissions lower.
Well, that's
quicker.
it, because in the truck world, with Euro 6, that's pretty damn clean as it is. And speaking of that, because diesel, people have in their minds, oh, dirty diesel, but it's not the case at all. I think the problem you guys have had and other engine manufacturers is the car industry didn't help with cheating emissions tests and things like that. They did not help anybody. But in actual reality, with you guys doing all this, this continued, validation, real world validation, PEMS testing, all that, it's a lot cleaner than it actually is.
Yeah. People have the misconception, but yes, it is a lot cleaner, and we do a lot more testing than I realized. So it's not just at the very start of a product; it's all the way through the end of its life. And so we're continually monitoring and making sure that everything that's out there that's our product is compliant.
Right. And then I suppose ultimately as well, your ultimate goal is zero emissions. Absolutely nothing being produced. So presumably this is where all your alternative powertrains and alternative fuels and all these other alternatives come into play.
Yeah, absolutely. So it'll be interesting to see how the testing changes, but for the PIMS portion, we have to test through the useful life, which is 7 years. With Euro 7, I think it'll be 10 years. So we'll be testing diesel trucks for a very long time. Yeah. But Cummins is definitely looking at different platforms and how to kind of integrate them to obviously our core business of diesel.
So, in terms of actual numbers, for a lot of people that don't follow the emissions cleanup, how far have you come since it all kicked off, which would have been, I don't know, late 90s, early 90s to where we are now? Yeah. How clean have you got them?
So since then, there's been a reduction of 97% for non-road.
Right.
So it's a pretty big jump.
It's a fair chunk then. Yeah. So there's not a lot left to clean up, but you can never go too far, I suppose. And just before we get rained off, just talk us through, some of this PEMS equipment here, just sort of from tailpipe to analysis. Yeah,
so this is a pretty good example, but you can see the heated line in the back. So that's basically taking the exhaust straight from kind of under the truck. It's keeping it at the correct temperature into the kit. Through here, that's where all of the emissions are measured. It's all inputted into the system controller, which we connect to. And basically, this kit takes all of your emissions and gives you a nice output where you can look at your temperature, your exhaust flow meter, all of your emissions, and your conformity factor, which is the most important.
Well, thank you very much for that, Logan. That has been absolutely spot on. Fascinating insight to the world of emissions and what you guys do here at Cummins.
All right. Well, thank you.
Thank you very much for your time.